All right, guys. So again, this is part 5 of our Unit 1 notes. If you're watching this on video, we just had everyone go through these links to do this warm-up. So you can follow this path, and I'll show y'all in its learning what it looks like. So you go to Resources, Unit 1, Links to Resources, and Radian and Degree Practice. And then they were doing the Radian and Degree Quizlet one. And I would recommend opening it in a new tab or window. And then there's these other resources you can always feel free to use and practice with. Thank you. Okay, so then back to here, I had everybody try to fill this in. If you're watching this on video, pause and see if you can remember the important degrees and radians, and then unpause to get it filled in to check. Those of you in class here, you've already had time to try and fill it in yourself. So what were the important degrees that we've been trying to, we've filled out in the table a couple times now? 0, 30. What was between 30 and 60? 45. Okay. 90, 180, 270, and 360. Very good. Okay, and I was short a row here. My bad. All right, so who remembers radians of 0 degrees? 0. 0 is 0. Okay, now you may not fill it in order. Maybe you jump around. Maybe you go down here and say, I know 180 is pi, and I know 360 is 2 pi. Okay, that's the semicircle and the full circle. Half a rotation, a full rotation. Okay, so those 3 you definitely need to have down. Okay, now in between those, you may say, okay, well, I know 90 is half of 180, and then maybe you fill in your halves next. So that's pi halves, or pi over 2. And then you notice 270 is 3 pi halves. So if you prefer to fill those in first, if you know those quicker or better, that's fine, or you can go in order, but all of these eventually you're going to need to have memorized. Okay, so 30 degrees was what? Pi 6. Good. It's a 1/6 of the way to pi, which is 180. 6 times 30 is 180. Okay, what was pi, 45? Pi 4ths. It's a 1/4 of the way to pi. 4 times 45 is 180. And 60? Pi 3rds, because it's a 1/3 of the way to pi. 3 times 60 is 180. Good. This column is what we're going to learn today. We're going to be able to fill in what are the ordered pairs at the points on what's called the unit circle. Okay, so I handed out that blue page with the unit circle on it. If you're watching online, you can get this. That's not it. This one. Okay, it's this blank page with, or it's not a blank page. It's this unit circle with all these blanks on it. Okay, and that's in the blank notes folder. Okay, so we're going to go through and talk about what is the unit circle and eventually be able to fill in the rest of this table with ordered pairs. Okay, so the unit circle is a circle with a radius of 1 centered at the origin. Okay, so centered at the origin. So the middle of the circle is at 0, 0. And then it has a radius of 1, meaning I can go in any direction from the center to a point on the circle, and that is 1 unit long, hence the unit circle. Okay, now let's think about this in terms of ordered pairs. Okay, so if you have this circle drawn on your XY axis and you have points on the circle at various angles, and you want to know the ordered pairs of those points, these 4 that are on the X or Y axis are the easiest. if the radius is 1 unit long, what's the ordered pair at this point that is 0 degrees or 360 degrees? It would be 1, 0. Okay, that's this point right here. Okay, you're going over 1, up 0. Now, if you're at the point at 90 degrees on the unit circle, what's the ordered pair? 0, 1. Good. You went over 0, up 1. And if you're at 180 degrees and intersecting the units, that point on the unit circle, -1, 0. You went left 1, up or down 0. And then if you're at 270 degrees here, 0, -1. Good. You went over 0, down 1. Do those 4 points make sense? Okay, let's go ahead and put those on that table. Okay, so we said 0 degrees, a point on the unit circle would be at 1, 0. And we're going to repeat that point at 360. So you can write that one twice. Okay, we said at 90 degrees, it would be 0, 1. At 180 degrees, be -1, 0. And at 270 degrees, it'd be at 0, -1. So those all look kind of similar, so be careful and make sure the 0 and 1 are in the right spot for X or Y, and that you have the negative when it's necessary on the right value. Okay with those 4 points? Okay, on your blank unit circle, let's go ahead and fill those 4 in. Okay, so that point here was 1, 0. At 90, it was 0, 1. Then here it was -1, 0. And then 0, -1. So I'm going to use 3 colors on my unit circle. I know yours that I gave you is printed on blue, so I don't know exactly what colors you have that will show up that you'll be able to distinguish between. But I'm going to do 1 color for the ordered pairs as we learn those. Now inside the circle, there's 2 blanks. There's spots for 2 values. That is and you can see the degree symbol. So one of them is the degree measure, and next to it is the radian measure. So that's what I'm going to go ahead and have us fill out right now. Okay, so let's go around first in degrees, because I think that's what most people are comfortable with. We learned this is 0, and if you made a full circle all the way around, you'd be back at 360. We went through, we said the special angles that we need to know are 30, 45, and 60. And we know that this is 90 degrees. Now, just thinking about this pattern when you're filling it in, look at what you're adding. So you start here, you go plus 30, plus 15, plus 15, plus 30. That pattern's going to repeat. Plus 30, plus 15, plus 15, plus 30. Okay, so I'm going to write that off to the side. From the beginning, it's plus 30, plus 15, plus 15, plus 30. And then you start over for the next quadrant, and then you start over for the next one. So if that helps you to fill in the degrees, you may want to jot that down. Okay, so I'm at 90, plus 30 is 120, plus 15 is 135, plus 15 is 150, plus 30 is 180, plus 30, plus 15, plus 15, plus 30. Okay, so we're going around and getting all these values. Plus 30, we at 300, 315, and then 330, and that full circle was back to 360, back to that starting point, positive x-axis. Question about degrees? Okay, I'm going to put above this. This is the pattern for degrees. That's helpful to you. All right, now radians. Now in radians, most people don't go around in order all the way around the circle and are able to fill all of them in because they're by different fractions. And so what's probably the more common method is to go fill in by, like we did on our, I'm going to pull it up and show you how we did on part, I think it was 3 of the notes. Let me just double check real fast. Yeah, it was part 3, how we went through and we did by 45s. And then we did by 60s. And then we did by 30s. Okay, that's probably the more common method because you're counting by that same denominator all the way around. But it's up to you. However you learn it and are able to fill it in, that's great. And get back to our unit circle. Okay, so the easiest angles, the ones we filled in on the table during the warm-up first, was 0, we know is 0 radians. 90 was pi halves. Bless you. 180 was pi. 270 was 3 pi halves. And then 360 was 2 pi. So maybe those are the ones you want to fill in first because they're what you're most comfortable with. It's probably what you're going to learn first and have memorized first. Okay. Then perhaps you want to go by the 45-degree angles, or maybe you want to go by the 60s first. It really doesn't matter. Does anybody have a preference? What do you want to count first? No? All right, well, I'll go in the order we did it in part 3, which we did 45-degree angles first. So we said 45 degrees is pi fourths because it's a quarter of the way to pi. Okay, so I'm going to go every 45-degree angle. That's the middle one in each quadrant and then each axis. So this is 1 pi fourth, 2 pi fourths, it's already written there, reduced, 3 pi fourths, 4 pi fourths is already reduced to pi, 5 pi fourths, 6 pi fourths is already reduced to 3 pi halves, 7 pi fourths, and then 8 pi fourths is reduced to 2 pi. Okay, then maybe you want to go around by 60s. 60 is the highest in each quadrant, the highest of those 3 angles, the point furthest away from the x-axis in each of the quadrants. Okay, so that is thirds. So we go around and we say 60 is 1 pi third. And this 120 would be 2 pi thirds. 3 pi thirds already reduced. 4 pi thirds. 5 pi thirds. And then 6 pi thirds is already reduced to 2 pi. So now the only thing we have left are the 30-degree reference angles. These are the 4 in the quadrants that are closest to the x-axis. Those are measured in sixths. 30 is pi sixths. But remember, when we're going around counting, we have to count all the 60, every 30 degrees counts. So this is 1 pi sixth, 2 pi sixth, 3 pi sixth, 4 pi sixth, and now here to the first blank, the next blank, 5 pi sixths, 6 pi sixths, 7 pi sixths, 8 pi sixths, 9 pi sixths, 10 pi sixths, and then this last blank is 11 pi sixths. So now we have all of the degrees and all of the radians around the unit circle filled in. Those are all of the special angles that we need to know. Some people notice patterns in the radians, like you may notice your thirds are all the furthest away from the x, fourths are in the middle, sixths are closest. And then for the numerators, some people notice it's like there's different patterns, there's different techniques for learning that. And I'm going to actually pull up and show you that in It's Learning again, those links to resources. Underneath the degree and radian practice, there's one called Learning the Unit Circle. And these websites have some tips and tricks and things for learning the unit circle. Some of them are for learning the coordinates. Some of them are for practicing the radians and degrees all the way around. Okay, so this one is a unit circle song for radians and degrees. There's this one, it's like a left-hand trick. I'm not even sure, I can't remember off the top of my head what it is, but you could check out these websites too to help you learn how to fill in the unit circle, to help you memorize how to fill that in. Any questions so far? Okay, so important radians and degrees. Now we're going to look at how do I fill in these ordered pairs. These are coordinates, x, y values. So from the origin 0, 0, I need to go over x and up y. I need to figure out what those distances are so I can put that ordered pair. So the way we're going to do that is by using our special right triangles that you originally learned in geometry when you did your right triangle unit. You may or may not remember these ratios, but they're listed here, and we're going to use them to find those ordered pairs. So I'm going to start with 45 again. So 45 degrees, the ratios of a 45, 45, 90 triangle. That's one of the special right triangles. The ratio of the side lengths of a 45, 45, 90 are always x, x, x squared to 2, meaning the two legs, the sides across from the 45s, are both equal to each other. And whatever that measure is, you multiply it by square root of 2, and that's the side across from the 90, the hypotenuse. That ratio is always true for all 45, 45, 90 triangles. You may recall in geometry, the reason they are special, we learned, is that you only have to know one of the sides, and then you can find the other two using those ratios. Where up to then, to find a missing side of a triangle, you had to know the other two to be able to do Pythagorean theorem. Okay, but with the special right triangle, if it's these angles, you only have to know one side. Now, in our case, this is a clip from the unit circle, okay? This is quadrant 1 here. This is the radius of the circle at 45 degrees. Okay, so I am trying to figure out how far over and how far up do I go to get to that point, because the length of those legs will be the x and y value here, because that's how far over, that's the x value, and that's how far up, that's going to be the y value. Does that make sense? Okay, so I'm creating this right triangle using the radius of the unit circle as the hypotenuse. Okay, so this is an ordered pair here. This is 0, 0. This is the center of the unit circle. And this is the radius of the unit circle, which we said is 1. That's what makes it the unit circle. It is 1 unit for the radius. So now I have a 45, 45, 90 triangle. I know it's 45 because this is at 45 degrees, which means that other angle must be 45 as well. So in a 45, 45, 90 triangle, we just got through saying you only have to know one of these 3 sides, and then we can use these ratios. So I'm going to bring that knowledge that the radius is 1 over here and solve for the other sides. Okay, so the radius, is that one of the legs or is that the hypotenuse? That's the hypotenuse. So in this table, I'm going to put that measure here. It's 1. Okay, you may or may not have been taught to use this little grid to organize your special right triangles. You may have written them out differently. I always, when I taught geometry, just use this because it's a good way to organize the information. I say, here's the angle, here's the ratio for the side across from that angle, and then this is for the actual length of that side. Okay, so that means that these two rows, these are equal to each other. Okay, so I'm going to set them equal. I'm going to say x square root of 2 equals 1. And you could label it in this picture here if you wanted as well. This side is 1. How am I going to solve for x? How do I get rid of that times square root of 2? Divide. The opposite of multiply is to divide. So I'm going to divide by the square root of 2. What you do to one side, you do to the other. So it gets rid of the square root of 2 over here, and I'm left with just x. Now, the issue here is we have a radical square root in our denominator, okay? And we don't like that. We need to rationalize that. So remember toward the beginning of last week when we first started our Unit 1 notes, we kind of reviewed rationalizing, okay? In case you had forgotten it from algebra or algebra 2. Does anybody remember what we did last week to rationalize a denominator? Yep, we multiply by whatever the square root is, we multiply by it. So we're going to multiply by square root of 2. Now, so that we're not actually changing the value, we have to do that to the numerator as well. So technically, we're really only multiplying by 1 because anything over itself is 1. Okay, now the reason we do that, the reason we multiply it by itself is that's squaring, right? And that's the opposite of square root. So the whole point of that was to get rid of the square root. Now it's just a 2 down there. So we got rid of the radical in the denominator, but it made the numerator 1 times square root of 2, which is just square root of 2. So this is the x value, square root of 2 over 2. That means across from the 45-degree angles, both of the legs, that's their length, square root of 2 over 2. That means on my unit circle, that is how far over and up I am going. Which means those are the coordinates of this ordered pair. This point here on the unit circle is at square root of 2 over 2, square root of 2 over 2. We knew going in that they were going to be the same because it was a 45-degree angle. That means it's an isosceles right triangle. That means the legs are equal. Are y'all okay with how we came up with that? All right, so let's fill that in on our unit circle. At 45 degrees, this ordered pair, this point right here, is square root of 2 over 2, square root of 2 over 2. I'm also going to go ahead and fill that in on the table at the beginning of the notes. At 45 degrees, that ordered pair came out to be square root of 2 over 2, square root of 2 over 2. Any questions yet? Did y'all recall the 45, 45, 90 special right triangle? Maybe you didn't remember what the exact ratios were, but you kind of remember learning about special right triangles. Okay, and that the legs are equal in a 45, 45, 90. Okay. All right. So the next one we're going to look at is here at the 30-degree angle on the unit circle. We want to try and find the coordinates of this point, this ordered pair. Okay, so I am going to do the same thing. I clipped out that portion, that quadrant 1, just showing the radius at 30 degrees. So it creates a triangle. I want to go over and up and use the radius as the hypotenuse. We create this right triangle, and it's a special right triangle because this is a 30-degree angle. This point here is 0, 0. So I want to find this point. So I need to find the leg lengths here. How far over and up, and that will tell me my ordered pair. All right, so I'm going to review 30, 60, 90. The other special right triangle you learned about. Its ratios were the shortest leg, so the one across from the 30, because 30 is the smallest angle. The shortest leg is X, so across from the 30, and call that X. Across from the long leg is, so across from the 60 is X square root of 3. So whatever the short leg is, we multiply it by square root of 3, and that gives us the long leg. And the hypotenuse across from the 90 is 2x. So the hypotenuse is always double the short leg. Those are always the ratio of the side lengths of a 30, 60, 90. Now in this case, our hypotenuse is 1 because this is the radius of the unit circle. So I'm going to label that in my table and on my picture here. So again, that means that these two are equal. So they're telling us that 2x equals 1. How do I solve for x? How do I get rid of times 2? Thank you. Divide by 2. So x comes out to 1/2. Don't have to worry about rationalizing or anything, so we don't have any square roots yet. Okay, so x is 1/2. So that's the side across from the 30. That's the short leg. Now, the long leg is that x value times square root of 3. Okay, so if I take 1/2 times the square root of 3, when you're multiplying a fraction, you just multiply straight across. This is understood to be over 1. So that's just square root of 3 over 2. It's already got the radical in the numerator, no rationalizing necessary. So that means the leg across from the 60, the long leg, is square root of 3 over 2. So when I take this information back to the unit circle, I say, okay, so the adjacent leg to the 30, the long leg here, is square root of 3 over 2. And the vertical leg, the short leg, is 1/2. That means as an ordered pair, this point on the unit circle at a 30-degree angle is square root of 3 over 2, 1/2. So I'm going to go back and I'm going to fill that point in on my blue unit circle page and on the table at the beginning of the notes. Okay, so on the unit circle, that's at 30 degrees, square root of 3 over 2, 1/2. And on the table at 30 degrees, that's square root of 3 over 2, 1/2. So far, so good? Now, the last angle in quadrant 1 that I need to find the ordered pair for is this point here at a 60-degree angle. Now, if I were to draw this triangle, so let's just think about this before I show it to you. If this is a 60-degree angle down here and I create the right triangle, 60 degrees would be down here. What's going to be the other acute angle of the triangle? 30. So it's still going to be a 30, 60, 90 triangle. It's just reoriented so that the 60-degree angle's down here at the origin. Y'all understand that? So what's going to happen, I have the same table, the same ratios, but notice it's redrawn here. So now the radius is still 1. It's still the hypotenuse of the triangle I'm creating. But now the short leg is how far over I go, and the long leg is how far up I go. So we don't have to go through all the math again. We know that the hypotenuse was 1. We know that that meant x was 1/2. And x squared of 3 is square root of 3 over 2. Now what that means in labeling your triangle is the 1/2 is across from the 30. So now that's down here. The square root of 3 over 2 is across from the 60. And it's the 60-degree angle that's down here at the bottom here. So if we start from 0, 0, and we go over 1/2, and then up square root of 3 over 2, that xy value literally just switched. Because the legs are the same lengths, they're just, now this is the x, the horizontal, and this is the y, the vertical. You just reoriented that triangle to put the 60-degree angle at the bottom. Y'all okay with that? So when we fill that in on our unit circle and on our table, 1/2 square root of 3 over 2, 1/2 square root of 3 over 2. These two right here are often mixed up. Those are really frequently switched around, and it's understandable because they're the same numbers, just in a different order. So the memory trick that I tell my kids to use that's helpful, I think, is that 30 starts with 3. So the square root of 3 comes first at the 30. So 30 starts with 3. That's my little tip for remembering. The square root of 3 over 2 comes first here. The 1/2 comes first here. Okay? All right, so we've got quadrant 1 of the unit circle completely filled in with our ordered pairs. That's what I want you to focus on studying this weekend. You still need to finish up the Delta Math for degree in radian. No new homework. Y'all have a great weekend.
Have a good day.
Thank you, you too.